Okay, is the screen visible?
Yes, ma'am.
Okay, we can start now. And we are entering into the week 7's problem solving session to our course Operations Research. Myself, Jayana Agasri, a teaching assistant to this course. In this week, we know that our syllabus is related to sequencing problem. Just a minute. So to solve that sequencing problems, there are four different kinds of situations arises that are n jobs and two missions, and n jobs three missions case, and n jobs m missions case, and two jobs n missions or m missions case. So all these are four different kinds of situations that may arise in sequencing problem. In those cases, we see the problems how to solve in this week. So first coming to our problem, which is related to n jobs and two missions case. Before looking into this problem, we just see the some definitions or notations related to sequencing problem. We know that in our sequencing problem, either in any of the case like n jobs two missions or n jobs m missions two jobs m missions case, in any of the case our main objective is to minimize the total elapsed time. Total elapsed time in such a way that our sequence is in order for a particular sequence or particular order. So first we have to find out that particular sequence to that problem, and here you can see the notations that are processing order is. What is the processing order? That means the order in which a job has to be processed on different missions. We have the different missions so that the process has to be completed on all the missions. All the jobs has to be completed on different missions or processed. So here it is the correct answer for the third processing order. And what is an idle time means the time for which a mission remains idle before completion of all the jobs. That means our main purpose is to complete all the jobs on different missions. In such a way, if the mission is remains idle, then the time is known as the idle time. And we know that the time between the starting of the first job and the completion of the last job, including any of the idle time, is called the total elapsed time. And no passing rule states that, or no passing rule or passing is not allowed. We can observe in problems or questions that passing rule is not allowed. That means that same order of execution of jobs to be maintained on each mission. That means if the problem is given, here can see for the jobs 1 to 5, mission A has to be done. In an order, jobs 1, 2, 3, 4, 5, first is mission A and then mission B. That type of order is only allowed. No other orders are allowed. That means passing is not allowed. Okay, coming to our first question, n jobs and two missions case. Here first to find out the problem is that the optimal sequence for processing the job is, that means first we have to find out the optimal sequence, then we can find out the total elapsed time, idle time for mission A's and mission B's. First we first find the optimal sequence. In to find out that optimal sequence, requirement is first we have to select the minimum time or minimum processing time from the all the missions, mission A and mission B. First we have to select the minimum processing time. Here we have 5 jobs, so that we may get the order sequence of 5 jobs. Sequence of 5 jobs. Which job has to be completed on which mission first? That is we are finding here. So first the minimum time is 2, which is related to the mission B. If the selected minimum processing time is related to mission B, then we have to assign the corresponding job at the last of the sequence. It is job 2. If the minimum time is coming from the mission A, then we have to assign the corresponding job from the initial beginning of the sequence. So here we find that 2 is minimum and the corresponding job is 2. uh, this 2 minimum is coming from the mission B, so that we had assigned the corresponding job at the last of the sequence, and cross it out that job. Here we just assume that this job 2 is crossed out because we are already assigned in a sequence. And then next find out the next minimum value. Here you can observe the 3 minimum value. 3 is involved in mission A for the job 1 and mission B for the job 4. So we can assign for job 1 related mission A's and job 1. So we can assign it in the starting of the sequence, and here 3 is from the mission B, so that we can assign these corresponding job 4 at the end of the sequence 4. So these and these jobs also crossed out, and remaining from the remaining times the next minimum value is 4. You can also observe that 4 is from mission A and also mission B. So you assign the mission A's 4 is minimum, so that you can assign the job 3 at the starting of the sequence, and mission job 5 at the end of the sequence. Here. So we obtained in sequence order is 1, 3, 5, 4, 2. Here from the options 1, 3, 5, 4, 2. Here it is. And next our purpose is to find out the minimum time or total elapsed time and idle times. First we have to cross check it. So our finally we got the order of the jobs is 1, 3, 5, 4, 2. So in this order of jobs, our missions are working, so that the minimum elapsed time we have to find out and idle times for both the missions. Here you can see in time, that is the starting time, and out time, finishing time for mission 1 or mission A here, and mission B in the same in time, out time, and taken another column for idle time for mission B. Without taking this column, we can find out the mission A's idle time. I will tell you how it is. So in time and out time. So for the first case, mission 1 is processing. You can see that. So initially, before entering into the missions, there is an in time is 0, initial time is 0, and mission A for the job 1 is processed for 3 hours. Here it is time in hours. So it is processed for 3 hours. So out time is from 0 to 3 hours. 0 plus 3, it is 3. So mission A should be relieved after processed 3 hours of time for the job 1. And in time of the mission B is after mission A is completed, then only mission B will be entered into the processing. So the in time for mission B is 3 hours, and out time is mission B is processed 6 hours for job 1. So entering time is 3 and processed 6 hours. So the out time is 3 plus 6, 9 hours. Here it is 9 hours. Here idle time for mission B means for doing the job 1, the mission B is entered at the time of 3 hours. That means up to the 3 hours mission B is in idle state. So here you can say that 3 hours mission B is at idle state. And In the next case, the starting time of mission A is mission for doing the job 1, mission A get to relax right after doing 3 hours. So next doing the next job, the entering time or in time is 3 hours. And completing the third job on mission A, it is the 4 hours of time. So here 3 plus 4, it is 7 hours of time at the out time for mission A is doing the job 3. And in time for the mission B is here to complete the third job, mission A took 7 hours. So mission B can be entered into the 7th hour or here you can see that before doing the first job, it is taking 9 hours to complete the first job only. So here the in time of mission B would be maximum of out time of the mission A's or previous out time of the mission B's. So here you can see that maximum of 7, 9 that is equal to 9 hours. At the 9th hour only mission B can process the job 3. So this is the in time for job 3 mission B. And out time is for the job 3 the processed time for mission B is 7 hours here. So he in time is 9 hours and out time is 7 hours. 9 plus 7 is 16 hours is the out time for mission B. And here you can see that idle time is mission B is in time and previously out time is same. So there is no idle time for mission B. Or here you can say that idle time for mission B is equal to sum of I is equal to 1 to n. Starting time of mission B minus out time of for the ith job. Out time of mission B for I minus 1th job. Here we are taking this difference in this column and finally to sum up that then we can get the ideal time for mission B. And coming to the next job, 5th job, the in time for doing the 5th job is for on mission A is 7 hours because here is the out time is 7 for mission A, and to process the job 5 on mission A is 7 hours. 7 plus 7 14 hours is the out time for mission A, and entering time for mission B is maximum of out time of mission A and out time of mission B. Here you can observe that 16 is the maximum, so it is 16, and out time is 16 plus processing time of mission B on for job 5 is 4, so it is 20, and here you can see the difference is 0. And to do the process job 4 and mission A, in time is 14, out time is 14 plus 5 to do the job 4 5, so it is 19, and in time for mission B is 20 for job 4, maximum of 19 and 20 is 20, and out time for mission B for job 4 is 3 hours, so 20 plus 3 23 hours, here it is, difference is 0. And to do the job 2, it is in time is 19 hours, out time is 19 plus job 2 is for doing mission A 7 hours. 19 plus 7 26 hours, and in time for mission B is 26 hours. So because maximum time is 26 here, and out time is 26 plus 2 28 hours, and here the difference is the mission B has waited 3 hours. Here its out time is 23 hours, but here in time is 26 hours, so it has waited 3 hours to process the job 2. So finally we get this table. So from this we can find out the total elapsed time, that is the difference between Total elapsed time or minimum time? That is the difference between finishing time of the last job on mission A and mission B. What is the difference here? Finishing time of the last job on mission A is 28 and mission B is 26. Sorry, mission B and mission A. That is equal to 2 hours. Here, total elapsed time is 28 hours to complete the last job on the mission, on all the missions. To process the time is 28 hours. This is the total elapsed time here, and this difference is called an idle time for mission A. Idle time for mission A is 2 hours, and total elapsed time is 28 hours to complete uh, all the jobs in a sequence is 28 hours. It is total elapsed time or minimum time, and idle time on mission B is 6 hours. So from the answer it is correct, 28 hours minimum time, and idle time is 2 for mission A and 6 hours for mission B. Yes. So it is the correct answer. Is there any doubts?
Ma'am,
Mm-hmm.
ma'am, for idle time of A, we should subtract ma'am out time of B minus out time of uh, A, final
A.
ma'am, final
A.
out time of.
Yes.
So we have to subtract like 28 minus 6 ma'am. It is ma'am final out time of B minus final out time of A. That what we are getting in the last row ma'am. That we have to subtract from 28 minus 26.
Yes.
For idle time of A only, na ma'am.
Yes, for idle time of mission A only.
Okay ma'am.
Idle time of mission B is here we had for each job we had considered in this column, and then adding all those, that is the idle time for mission B. As this is only the optimal sequence path, that is minimizing the total elapsed time. If you consider any other sequence and check it, then the total elapsed time here we obtained is 28 hours. If we considered any other sequence, then total elapsed time might be greater than this. Who asked the question in chat box? For them I told. This is only the optimal sequence. It's correct. And coming to the next question, that is, before we had seen that n jobs and 2 missions. Next we see the n jobs and 3 missions. There is no specific method to solve the n jobs for 3 missions. We only convert that 3 missions case into the 2 missions case. So to convert that problem into 2 missions case, there is a criteria that should be satisfied. Then only you can convert the 3 missions case into 2 missions. Otherwise, we can't solve the problem. Then what is the criteria? If anyone knows that here AI, BI, CI are the 3 missions. Mission AI, mission BI and mission CI are the 3 missions. Then what is the criteria to convert 3 mission case into the 2 missions? and assume that there are n jobs.
Ma'am, first option, ma'am.
First option you said. That means minimum of mission A. First we need to find out the minimum values from mission A of all the jobs, and the maximum of mission B, and minimum of mission CI. Then the criteria is that minimum of mission AI should be greater than or equal to max of mission BI's value, or from the first option, minimum of mission CI should be greater than or equal to max of mission BI. Either of this, not both. If either is satisfied, then we can convert the 3 missions case into the 2 mission case. So how we can convert this into 2 missions case? Suppose we assume that mission G and mission H are the 2 missions. For converting 3 missions into 2 missions, it has the times, that is the sum of mission AI and mission BI values it takes. And for the another mission, it takes the sum of mission BI and mission CI values. Then we can convert the 3 missions case into 2 missions case. And now we see how to solve 3 missions case problem. So find the particular sequence that minimizes the total elapsed time required to complete the following tasks. Tasks are jobs here. So these are the 3 missions case. To solve this, first we have to convert the 3 missions into the 2 missions case. The criteria is minimum of AI. Here minimum of mission 1. First select the minimum of mission 1, that is 3, and the maximum of mission 2, that is 5, and minimum of mission 3, that is 5. So our criteria is minimum of mission 1 should be greater than or equal to max of mission 2. Check it, is it true here or not? Minimum of mission 1 is 3, is greater than or equal to max of mission 2, that is 5. No, it was not correct. And another criteria is minimum of mission 3 should be greater than or equal to max of mission 2. Mission 2 only. Minimum of mission 3, 5, greater than or equal to 5. Yes, it's 2, right? Equal to sign. Don't forget about equal to. So it is true. Our second criteria is hold. So that we can convert these 3 missions case into the 2 missions case. How we can convert this? First, we need to add the mission 1 and mission 2 values for the first mission. Let's suppose it as mission G. Mission G. Here task A, B, C, D, E, F and G. They are the 7 tasks or 7 jobs. Now we have considered the 2 missions. Mission G has the sum of the values of mission 1 and mission 2. That are, if we add that, 3 plus 4 7, 8 plus 3 11, 7 plus 2 9, like so, 10, 12, 10. And mission H has the values of mission 2 and mission 3. Mission 2 and mission 3 is 10, 16, 6, 10 and 15. Right. So we had 2 missions and n jobs and 2 missions case. Now we can find the optimal sequence. In the previous way, like first we have to select the minimum from the 2 missions. The minimum value is here 6. So corresponding job is E, and which is from the mission H, second mission. So we have to assign that E at the last of the sequence. We had 7. So at the end of the sequence, we have to mention the E and cross it out. Next minimum value is 7, which is from mission G. So we need to assign at the starting of the sequence. And next most minimum value is also the 7, which is in mission H. So we need to assign C at the end of the sequence. And next minimum value, you can observe that 10 is appeared at 3 places, 1, 2, and 3 places. Corresponding other jobs values, we have to see that first. Here, if you see the 10 values, corresponding highest value is 15. So first we take the G at the end of the sequence, because sorry, mission G is from the mission G, so it is from the starting of the sequence, and cross it out. Uh, oh, sorry, here we are left 9. Next most minimum value is 9, which is from mission G, so we need to assign at starting of the sequence, that is D, and cross it out. Next G, and next there are 10 from B and 10 from F jobs, but both are coming from the mission H only. So there are the two sequences that might come. First is B and F, or F and B. So sequences might be changes. That means they are the two sequences you can get: A, D, G, B, F, C, E, A, D, G, B, E, F. I think first one is correct. But most of the cases we see, to find out the time calculations, first assign the F value at the last. Why? Because the corresponding other jobs value 12, which is maximum, than the 11. So first assign the corresponding job at first or last, based on the coming from which job it is. Here it is coming from H, so first assign F at last. Why? Because the corresponding other jobs value is highest for F. So in any of the sequences we can find out the total elapsed time, idle times, for mission 1 and mission 2 and also mission 3. In that cases, the total elapsed time may not be changed, but idle times may change. Here you can see how to find out the total elapsed time and idle times for the 3 missions. As before, we can assign the task here, and mission 1's in time, out time, and mission 2's in time, out time. In this case, here consider the idle time for mission 3, mission 2 and mission 3. There are 3 missions. And mission 1 idle time can be find out at the last of the process. Okay. Our sequence is A, D, G, B. Is it so? So in this case, the in time for mission 1 is, anyhow it is 0 at the starting, and out time is 0 plus mission A processing, mission 1's processing time on task A is 3. So out time is 3, and mission 2's time is 4 for doing the task A. So here in time is 3 and out time is 3 plus 4, 7. And mission 3 is in time 7, and out time is 7 plus, to do the process, mission 3's processing time is 6 hours for doing job A. So 7 plus 6, 13 hours out time. Here idle time for mission 2 for doing the job A is it has waited for 3 hours or 3 hours of time here. That is in time of mission 2 is 3 hours. 3 and mission 3 has waited for 7 hours to come into process the job A. And next we can see mission D's out time is 3 in time is 3 hours and out time is 3 plus D to the process 7, 3 plus 4 7. And here in time is maximum of the out time of mission 1 and out time of the mission 2. Here 7 same. And out time is 7 plus to the process of mission 2 is 5, 12 hours. 7 plus 5 12. And here the in time for mission 3 is in the processing of job A, it takes 13 hours only. But here the completion of job D on the mission 2 is 12 hours. But it has to be wait until finish the previous job only. So here the maximum value is 13. So in time of the job mission 3 is 13 to do the job 4 D. And out time is 13 plus 11 24. And here idle time is there is no idle time waited for the mission 2, that is 7 minus 7 0 and 13 minus 13 0 here it also. And coming to the mission 1 doing the job G, the out time is in time is 7 and 14. Are you getting how we are entering these values? And in time is 14, out time is 17, 24 and 36. Here 12, 24 plus 12, 36. And the mission 2 has waited for 2 hours, 12 to 14. There is a difference of 2. So here the idle time is 2, but mission 3's idle time is 0. And to do the process job of mission B, there is an in time 14 and out time is 14 plus 8, 22. And here the maximum value is 22. So the in time of mission 2 to do the job B is 22 and 22 plus 3 25. Here it is in time 36 because the maximum is 36, then 25 and 36 plus 7 is 43. And here there is a difference between 22 and 17. Oh, so it is the 5 hours it has waited. Mission 2 is waited for 5 hours and it is 0. Likewise, you can do the remaining also. Then finally you may get the total elapsed time as, here you can see, observe that. Total elapsed time is 59 hours and idle time for mission 1 is 13 hours, for mission 2 37 hours and mission 3 7 hours after doing all this. You can do it. And here the mission B's idle time is adding up all these, adding up these column. And mission 3's idle time is summing of these column you can get. And mission 1's idle time is the difference between at last we can get the for the last job we can get the process time out time of the mission 3 and that is minus the processing time of mission 1, that would be the idle time for mission 1. And total elapsed time is what is the time here we are getting to complete the last job, that is the total elapsed time. Is there any doubts? Okay, next we can come into the solving of n missions and m jobs, or n jobs, m missions. Then we can see the two jobs, m missions case. First, here to solve the n jobs, m missions case also, there is no particular method to solve this. We only convert this problem into the two missions case only. So to convert this into the two missions case, as there are the previous conditions, for this also there are the conditions. Uh, First condition is, if we suppose that T1J is the time to do all the jobs on the first mission. Likewise, T2J is time to do the all the jobs on second mission. That are the times. Likewise, we suppose that they are the M missions. So n time on the mth mission to do the job J is TMJ. Just suppose that. Then our first condition to satisfy is to convert the m missions case into the two missions. That is, first thing is minimum of T1J should be greater than or equal to max of T2J, T3J and so on, Tm minus 1J, m minus 1th mission up to that. That is the one criteria. And other is minimum of Tmj, that is the last mission's corresponding time values. That is greater than or equal to max of T1J, T2J and so on, Tm minus 1 into J. So if these conditions, any of these conditions, either not both, if any of these conditions are satisfied, then we can convert this problem m missions case into the two missions case by doing two missions as, suppose G and H are the two missions, that is summing up all the jobs, all the missions, that is T1J, T2J up to Tm minus 1J, that is 1, and from T2J to TMJ, this is another. That means first to third one mission it has adding up, and third to second to last, that is the time for another mission. So here if we see here, in our case there are the 5 missions. Jobs we are converting into two missions case, sorry. The jobs are A, B, C and D. They are the 4 jobs. We are converting into 2 missions case. 5 missions into 2 missions case. How we can convert that? For the job, here it is the time for job A. For the 1 to, have to consider 1 to Tm minus 1, that is 1 mission's time, and 2 to Tm, that is the another mission's time. Adding up this. First we need to check these criteria, right? First check it. Minimum of T1J is, what is the minimum of T1J? On mission 1, corresponding each job's minimum value is, here it is 7, and for the on the mission 2, for each job the minimum value is 3. Sorry, here we need to calculate the maximum value, right? First it is 7, and max of T2J is equal to maximum value is 7, and in a similar way T3J max value is 7, and max of T4J is 8, and finally we need minimum of TMJ. Minimum of TMJ is equal to 8. So now we check that minimum of T1J is 7, which is greater than or equal to max of T1J, T2J, T3J, T4J. Is it so or not? 7, 7 and 8. Which is satisfied for first, second and third missions, but it was not satisfied for the fourth mission. 7 is not greater than or equal to 8. So first condition was not satisfied here. And next condition is minimum of TMJ, that is 8, which is greater than or equal to max of T1J. Max of T1J is equal to 10. Oh, sorry, here we may not consider T1J. T2J is 7, 7, and T4J is 8. Max of T2J, T3J and Tm minus 1J. So it is satisfying all the criteria. Second criteria is satisfying all. So we can convert this M missions problem into the 2 missions case. So adding up the, while converting, we know the criteria that first mission has the sum of 1 to M minus 1 missions, and that means 1 to 4 missions. Adding up these, 9 plus 7 plus 4 plus 5, 18 and 25. It is 25, and for the B is 8 plus 3 plus 6 plus 7, 10, 24, and like so mission C, job C and mission for the first 4 missions, you can calculate that. I just tell you. This 28 and 24. To get the values of mission H that are summing up the from 2 to last mission. That is 7 plus 4 plus 5 plus 11. 27 and 28, 31, 22. So here we obtained the 2 missions and 4 jobs case. So to find out the optimal sequence, what is the criteria as seen before? They are the 4 jobs. First we have to find out the minimum value out of these values, that is 22, which is from the mission H, so assign that D at the last. And next minimum value is 25, that is coming from mission G, so assign A at the starting and cross it out these 2 rows or columns. And then next, sorry, here minimum value is 24, right? Next minimum value, so assign B and then assign A, and finally here is it is C. B, A, C, D. So first option is correct. And find out the minimum time as you find it in before. It is 65 hours. That is total elapsed time. Here we are not asked about anything on idle time. So just we only need to calculate the total elapsed time. Is there any doubts in converting the M missions into 2 missions case? Okay, we can enter into the 2 missions, 2 jobs and M missions case. So up to now we seen that all are N jobs and M missions. Mission's case. But here there is a particular situation that these are only two jobs and M missions. So this type of problem can be solved by using the graphical method, which is easier. And this graphical method we can call it as a Gantt chart or Gantt diagram. The type of solving graphical situation we can call it as a Gantt chart. So how we can solve it, I just show you. Our main objective is to find out the total elapsed time, minimum elapsed time, and idle times if any. So here it is 0. I am taking the distance of 2 units, 4, 6. Here assume the 20. The corresponding x-axis is belongs to job 1 values and it is belongs to the job 2 values. Y-axis is related to job 2 values. So from the given table we can observe that the processing time for doing the job 1 on mission A is 3 hours. Here they were not mentioned, we assume that hours. That is for 3 hours. So first make the 3 hours on the graph for job 1 only. So I am taking 3 on the x-axis. So make a line corresponding to x. And to do the job 1 on mission B after completing the mission A is 4 hours. That means the total time, that is out time to do the job 1 and mission B is 3 plus 4, that is the 7 hours. So make a mark it 7 on the x-axis, that is for job 1. So up to 3 hours job mission A is only on the processing, and from after 3 hours to 7 hours mission B is processing, and 4 plus 2 is 6, sorry 7, here up to we are coming into the 7 hours. 7 plus 2 is 9 hours. So to come to do the job 1 and mission C is 2 plus 7, 9 hours. So this is for mission C's. So here up to 9 hours, and then 9 plus 6, 15 hours on mission D, out time of mission D, and 15 plus 2, 17 hours is the out time for mission E. So the mission E for the job 1 is completed on the last mission is 17 hours. So in a similar way, here it is D, it is E from that time process. Similarly, we have to mark the job B's values for each mission. Here to first we are doing the process on mission B only, which is taking the 5 hours of time. So I mark it here. It is only for mission B's doing the job 2, and after 5 hours, 5 plus 4, 9 hours on mission C to do the job 2, and 9 plus 3, 11, sorry 12 to do the job A, and 12 plus 2, 14, it's for mission D, and 14 plus 6, 20 on mission E. So after marking this, uh, take the square or boxed area, a shading area that is corresponds to the intersection of each mission. Here you can observe that first one is corresponding to the mission A. Here mission A is at from 9 to 12 and it is from 1 to 3. So this box would represent the mission A's. So here if you observe that this is corresponds to mission A. And here it is B from 3 to 7 and B here it is in this area mission B is involved, mission this time, and for the mission C it is here, and D here it is involved here, and E at last it is here. So after doing this, take a 45-degree angled line passing through the horizon, and this means the jobs 1 and 2 are processing simultaneously. So if you take 45-degree angle, it will be intersect the B's box at 3. Here it is 3 point, so it can hit it on the 3 value if we go in this way, 45-degree angle. It hits at 3, and after that we have to go to, we may not go through the box, I mean we may not enter inside the box, we only go on adjacent sides of the boxes or the shaded region. Here the adjacent side is coming in this way upwards, that means the line is going on upwards, that means job 2 is processing, at that time job 1 is idle. Here it is, the distance is 3 to 5, this is the 2 hours of distance, and again we need to go for a 45 degree again, and it is 45. So if we go to on 45-degree again, it will be intersected at the point 9, 11. Here it is the 9, this line corresponds to 9 value, and here it is the 11 value. So it intersects at 9 and 11, this point. After that, why? Because here we stopped, means if we extend this line, it may intersect at the D's box at 12 and 10 or 12 and 10. Then again we need to go on the adjacent sides of this box. That means we can go in the straight forward of right side, or we can go backward. We can't go to the backward. Anyway, we have to minimize the path, so that we are stopped here only. That means 9 and 11 point. And after that we are going in a upward direction, because there is no minimum distance has covered in the upward direction, that is the distance is 11 and 14, there is a distance of 3 hours. If we go in this direction, so that means right side, here it is the distance from 9 to 9 to 15, that means 6 hours. If we hit it at 10, it is 5 hours, it is more than 3 hours, so we are preferred to go on upward direction. Again we need to go 45 degree, so it may goes in this way, and it can hit it at in this point. After that we have to go, there is no other way, so we only going to the right side in this way. Finally we reach at the final destination point, which is 17 on job 1 and 20 on job 2. Is it okay? So it is going upward, means job 2 is processing and job 1 is at ideal state, and it is going to the right side, means job 1 is processing, and at that time job 2 is idle. So here finally after doing all this, we can say that idle time for job 1 is equal to, here job 1's idle time is, the distance is 2 here. Here this is going upward means job 1 is at idle state, job 2 is processing. So here it is 2 plus here also it is going upward, that means job 2 processing, job 1 ideal 3, and there is no upward directions. So finally 5 hours of idle state for job 1, and here it is going to the right side means job 2 is idle. Idle time for job 2 is here, right side job 2 is idle for 2 hours, and finally the total elapsed time is equal to total processing time plus idle time for job 1 and job 2. Total elapsed time for job 1 is equal to processing time 20, oh sorry 17 plus idle time for job 1 is 5 hours, that means 22 hours, and the same time total elapsed time for job 2 is 20 plus 2 hours, that is 22 hours. Anyhow the total elapsed time is 22 hours for both the jobs, and here we also define the idle times here. So with this we had completed all the 4 different steps, 4 different situations arising in a sequencing problem. Here you can observe another question which is regarding the 2
Ma'am,
jobs emissions. Yeah.
in that question, ma'am, if that a total elapsed time was different, ma'am, then
Mm-hmm.
what we will do, ma'am? What is an optimum time? Then we will say, ma'am, the maximum time we will say that it is an optimum time, ma'am.
Yes. If
Like,
which job has the total maximum elapsed time, that would be the total.
oh, okay, ma'am.
If while comparing both jobs, which one has the maximum elapsed time, that is the total minimum elapsed time.
Okay, ma'am.
So here is a question that in a graphical method for processing the 2 jobs through emissions, if that graph moving to the right, that means that just now only I told, you guess what it is.
Ma'am, last option, ma'am.
So it is moving to the right side means job 1 is processing, while job 2 is idle. Here you can see easily. So moving to the right means in this way, that means job 1 is processing, job 2 is idle. Moving upward means job 2 is processing, job 1 is idle. Okay. In this week we are wind up. If is there any doubts, then you can clarify, otherwise is there any doubts? Okay, then we can meet on next week. Next week topics are on game theory only, right?
Yes, ma'am.
Okay. Okay, then now I'm going to terminate the call.